Hi, my name is Richard Berkowitz, and I'm the lecturer in the course Quantum Mechanics, which is your first course in quantum mechanics. Now, quantum mechanics has an interesting reputation. On the one hand, it is known as a very difficult subject. It's not intuitive. We have a lot of new concepts. It's hard to understand what's going on exactly. And one of the greatest physicists, Richard Feynman, has come up with the statement that anyone who thinks that he understands quantum mechanics doesn't understand it. On the other hand, quantum mechanics is actually, from the point of view of the mathematics, very, very built in the meaning that we have closed algorithms which enable us to almost like a machine go into the calculation, define our problem, define what we want to actually calculate or achieve, and come up with an answer. And in a sense, it's even simpler than classical mechanics. So how do we treat a subject which has such a disparity between understanding it and calculating it? Richard Feynman, again, quipped that, well, in quantum mechanics, students should shut up and calculate. That's actually not a bad recommendation. And during most of this course, most of the lectures in class will follow this recommendation. On the other hand, it's still important to try to understand the concepts and the physics behind quantum mechanics. And that's not easy, but that's the reason that we are filming these clips. The idea is to raise some questions about the strangeness of quantum mechanics. So we will be able to discuss them either after class or before class, or in some other venue that we will decide about. Okay, so actually what I would like to do in this clip is give you a taste of the strangeness of quantum mechanics, what stands behind it, and what type of questions can we ask. Now, usually one of the iconic experiments in quantum mechanics is a two-slit experiment. So one of the experiments that illustrates the strangeness and the unintuitive results of quantum mechanics is the double-slit experiment. I'm sure that some of you have heard about it, but I would like to illustrate the challenges to our intuition that quantum mechanics poses before us by describing the double-slit experiment, and before it, the one-slit experiment, which is important to get a general understanding on what these experiments actually give us. Okay, so we have the one-slit experiment and the two-slit experiment. And what is actually performed in these experiments? Before I'm describing exactly the experiments, it's important to note that already in classical physics, there was a big discussion, what is light? Newton believed that light is particles. So the one-slit experiment for Newton would be, you put a screen which has a slit in it, a hole in it. We put another screen on which we observe the light passing through. We shine light at the first screen. Light will pass through the slit, will be blocked by the screen. And if we are observing the second screen, we'll see a region for which light shines. We'll see a patch of light, a clear area where we have light. If we'll repeat this experiment for the two-slit experiment, meaning we have a screen which has two slits, again, we'll shine light through these slits. What we expect to see is just two patches of light. Okay, sounds reasonable. Unfortunately, or fortunately, when one performs this experiment with light, and Young is perhaps the first one who did this experiment, you don't see this phenomena at all. You see something else. You see a behavior that fits waves. So we take our one slit, we shine light, and what we see is a diffraction pattern. We see the main area where we have strong intensity of light, opposite the opening, opposite the slit, but we see side lobes. And that is a phenomena that is unique to waves, and if we see it, we know that we are dealing with waves. Again, I'll just emphasize that this is what we see on the screen. Okay, let's do it for a double slit. Again, we shine a wave, and we'll see here an interference pattern with strong fringes where we see strong areas with strong intensities, areas with almost no intensities, and if we see it in a double slit experiment, we know that we are dealing with waves. Okay, and that experiment was performed for light, and indeed, one is convinced that light is a wave. We know it also from a theoretical point of view. We see that Maxwell, which described electromagnetic waves, wrote down his famous Maxwell equations, and we get from it a clear understanding of classical light waves. Okay, what happens when we are performing this experiment, but changing slightly the conditions? And here we are dealing with a case where we start to see quantum mechanics in action. Okay, so again, we have our slits. We have our one slit. We have our two slit. We still shine light into this slits. The only thing that changes is that we go to very weak light, very low intensity. And if we sit and observe the screen, we can observe it by eye. It's a bit difficult. We can put a CCD camera, and then we'll see it much clearer. We will see the following behavior. We'll see a point on the screen where light shines momentarily, and then another point, and 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 so on and so forth. And in the end of the day, after we accumulated many measurements, we'll see a pattern that resembles the wave pattern. But when we observed each incident of light hitting the screen, we saw something that's very similar to what we expect from a particle. We'll go back and do it for the 2 slit experiment. Again, the same behavior will emerge. We'll see individual hits of the intensity of light on the screen. And if we wait enough time and accumulate enough measurements, we'll see a pattern that is very reminiscent of the interference pattern that we have seen for waves. On the other hand, as I emphasized, if we look at each incident, it reminds us a particle. Moreover, if we go and do the same experiment for electrons, which classically it's completely understandable that these are particles, electrons. Nevertheless, we'll see the same behavior. And actually, this was recorded in an experiment performed in a lab. And here you can see this behavior as a film where we see each time an electron impinging on the screen and a pattern accumulating. So this is a clue for our understanding on the strangeness of quantum mechanics. We see, on the one hand, we have elements of the behavior of the 1 slit and the 2 slit experiments, which remind us of a particle. We see each time a point glowing where light or an electron hit. On the other hand, if we accumulate these behaviors, a pattern that is very reminiscent of a wave interference behavior emerges. So back to the ages-old question, light or electrons, are they a wave or are they a particle? That's one question we will continue to discuss in the course. Thank you.